Okay, so in 13.5, like I said, all of this quiz, you need to be able to figure out what the amplitude is, given information, the midline, so on and so forth. The first thing that's important in this problem is the fact that we have a high tide of 7 feet and a low tide of 4 feet. This tide table is obviously going to be important. They wouldn't give it to you if it wasn't important. These A through B, you're not really answers these questions for you. We're just going to answer them on the bottom. Question says, what is the average depth of water at the pier? What is the, or D, that's going to stand for average? So average is not the A value, it's D, the midline. Middle, average is the midline for all problems of being for midline. And how do I find the average of something? Add them together. I have 7 and 4, so I have 7 plus 4. How many numbers are there? 2. So we have 7 plus 4 over 2, which is 11 over 2, or 5.5. So 5.5 should be your answer for the midline. Average is the key. And that's feet, by the way. Number 2, how can you find the amplitude of the variation from the average depth? The amplitude given the midline. Exactly. So really all the amplitude is the distance. So amplitude is the maximum minus the midline, or midline minus the minimum, but usually I like maximum better, it makes it pop. So amplitude is the max minus the midline. So what was the maximum tide? 7 feet. And then mine was 5.5 feet, so minus 5.5 feet, which is equal to 1.5 feet. Wow, that's 1. So these things aren't just written in words this time, instead of me saying, tell me what A is, tell me what D is, tell me what C is, so on and so forth. One cycle of the tide. What is the cycle length in hours? So how to find a cycle length? What is the one cycle? Kind of the period. It's how long it takes to get from the starting point back to the starting point again. So the length of one cycle is the time it takes for one complete pattern. So what you're looking for is, if we start at high tide, how long does it take to get back to high tide? So high tide to high tide. So how long does it? About 12 hours, yes. So that's going to be my cycle length. Number 4 says, how can you find a cosine? Models the relationship between the depth of water and the time of the day. So if I'm trying to write a cosine function, what do I need to know in order to plug that? The A value, the B value, C value. So I need to substitute A equals, what does A equal? 1.5, because that was my amplitude. B, we don't know yet, so we got to solve for that. C, is there a phase shift? Did it say anything about moving left or right? No, so C is going to be 0. And then what was the D value? So the only one we're missing right now is the B value. There are 2 formulas that we had that had B in it. We had C over B. We also had 2B, and usually that's the one we use. So 2 pi over B what is 2 pi over B a formula for? The period. And what did we say the period was? It was 12. So now I just have to solve for b to figure out what it is. So how would I solve for b? We would want to multiply by. So the b's cancel. I end up with 2 pi equals 12b. And then divide by 12. So b is equal to 2 pi over 12. Or how would I simplify 2 pi over 12?
Pi over 6.
Pi over 6. So now I have my b value over here. Now I just have to write my cosine function. So we have y equals, a always comes first, so it's 1.5, cosine, pi over 6, because that's my b, but b always has an x or a t or something behind it. Since we're talking for time, I'm going to put t there. We don't have a c value. Yes? No. It doesn't have to be. It would have to be if since we don't have a c value, you don't need a parentheses. A set of parentheses. So y equals 1.5 cosine pi over 6t, and then we have the last number in here. We have the d value, which is plus 5.5. So now I have my function. If you do not have a calculator, I strongly suggest, actually I don't strongly suggest, go get a calculator because you need it. Because in number 5 it says, how can you use a graph? And this graph would be a lot more complicated to do by hand and a lot more time consuming if we didn't use the calculator. A graph to find the times of day when the water depth is at least 5. Well, I'm kind of helping you through this, so I'm giving you the answers. We need to graph the function. So in y1, you're going to be typing in your 1.5 cosine pi over 6t plus 5.5. That's going to be in y1. We use x for t because we don't usually use the t. Then in y2, we're going to type in 5 because we're looking to see where it's at least 5. And then from there, we're going to find the intersection. Calculator. You need to make sure you're in radian mode, so if you haven't done that or checked that, you need to make sure you're in radians in order to do these problems. So mode, make sure you're in radian mode. Typing in 1 point cosine. I would suggest using parentheses for the pi over 6 part. I didn't already put a parentheses there, so I need another one. And plus. Pi over 6. What to do for a window. So my suggestion would be, so click window. We're going to go through. Yes, Camille? Probably won't help because